Good day. This is Group 5's ECNG3022 coursework project titled Linear Generators. Group members are Kiran Bola Singh, Govinda Hussain, Afraz Khan, and Surika Ramrup. Our research question was to investigate the effect of magnet frequency oscillation on the induced coil voltage of a linear generator, and this was to be modeled in COMSOL. From the 3D representation of the Faraday flashlight, a cross-section was taken and modeled using 2 dimensions in the software. 2D was chosen over 3D modeling since the cylindrical nature of the generator allowed rotational symmetry to be done. This was easily implemented in 2 dimensions as compared to 3D. Furthermore, 2D required less processing power to compute the result as compared to its 3D counterpart. The AC-DC module was chosen since it was ideal for electromagnetic applications. It provided multi-turn coil features for 2D modeling as well as 3D modeling, and Ampere's and Maxwell's laws could be applied to the system to obtain the required response. Here we have the 2D asymmetric model of the linear generator as developed in COMSOL. The 3 coils, the magnet and its encasing, and the air domain were all accounted for. The coils were configured such that the maximum output voltage was obtained. If, however, connected in series, the cancelling effect would take place and the output voltage would be reduced. Using the 2D model, a 3D animation was generated via COMSOL. Here, the magnet was simulated to oscillate at a frequency of 4.5 Hz, which is the maximum frequency of which a human can gesticulate in one plane. From this, simulated results were obtained as it pertains to induced coil voltages as well as total magnetic energy produced from the system. Voltage versus time was plotted from the simulation. Extrapolating the points, it is seen that the induced coil voltage is much higher at higher frequencies of oscillation as compared to lower frequencies of oscillation of the magnet. The peak coil voltages obtained were plotted against their respective frequencies of oscillations. As seen, a linear relationship was obtained, and this coincides with Faraday's law of electromagnetic induction. Graph of total stored magnetic energy versus time was plotted. From the graph, it is seen that regardless of the frequencies being used, the total energy stored is relatively constant. However, the power output at higher frequencies is much larger than that of lower frequencies. The surface magnetic flux density norm is comparable to the actual magnet being used. In conclusion, the linear generators model in COMSOL, a relationship was developed between the frequency and induced coil voltage, and for future developments, the implementation of a half-batch array can improve the system's operation.